Introduction to maximum and minimum point in mathematics. What is maximum and minimum point? Maximum point is the highest point on the graph, while minimum point is the lowest point on the graph. Saddle point is a point of a function or surface which is a critical point but not a maximum or minimum point. We can use differentiation to solve maximum and minimum problems. Let's go!
So, for the problem statement, we have chosen two different types of shapes which involve rectangle and also the combination of rectangle and semicircles. The first question is,
so the solution of first question is the total of y plus x is 280. So we move the 2x to the side and let the equation y equals to 280 minus 2x. So using formula area rectangular, we know that area of rectangular is width times length. So the width from this question is x and the length of this question is y. So we get the y value which is 280 minus 2x. So we put the value of 280 minus 2x inside the equation. So the equation must be a equals to x times 280 minus 2x. So the answer is 280x minus 2x squared. So the second question is find the maximum value of a. A equals to 280x minus 2x squared. We have to differentiate the equation first. We get the equation 280 minus 4x. So a maximum dA over dx equals to 0. So we know that dA over dx is 280 minus 4x. So we put equals to 0. Then we let 280 divided by 4. Then we get the value of x. So the value of a maximum is 283 times 70 minus 2 times 70 square. I get this question from the a before the differentiation. And then the answer is 9,800 meters square.
so that's the complete solution for question number 1. We proceed to question number 2. So let's say for the question A, obtain an expression for y in terms of x. Means that y will be a constant. But before that, perimeter has been given in the question, which is 400 meter. So we can use the perimeter to answer this question. Right? What is the perimeter? Perimeter is the circumference, which is we need to plus all the lengths of the outlines of the shape. This one is the length of the rectangle, which is y. This one is the length of the semicircular. But how to get the length of the semicircular? So here is the formula. 2 pi r over 2. So when we simplify it, we will get pi r. So the length of the semicircular is pi r. So the perimeter is y plus pi r plus y plus pi r equal to 400. When we plus y with y, we will get 2y. When we plus pi r with pi r, we will get 2 pi r. So 2y plus 2 pi r equal to 400. From the equation, we just have two variables of y and x. So we need to remove r by substitute r with x. So how? When we combine two semicircular, we will get a circle. So the diameter is x. So to get the radius, we need to divide x by 2. So we can substitute r with x over 2. Like this one, 2y plus 2 pi times x over 2 equal to 400. At this one, we can simplify it by 2 times 1 over 2, it will be 1. So the result is 2y plus pi x equal to 400. Remember, we want y as a constant, so we need to bring pi x to the right side. So it will be 2y plus 2y equal to 400 minus pi x. So it will be y equal to 400 minus pi x over 2. So this is the final answer for question A. So let's see for the question B. Show that the area of the track is given by A equal to 200x minus pi x squared over 4. So here we need to show the answer to be like this one. The first step is we must to know the formula of the area of the track. The formula of the area of the track is area of the rectangle plus with 2 area of the semicircular. The area of the rectangle is width times length. In the figure, the width is x, the length is y, so substitute them into the formula, it would be xy. Then, area of the semicircular is 1 over 2 pi r squared, so substitute the value into the formula, so plus 2 times 1 over 2 pi r squared. After the simplify, you will get pi r squared. When we look at this one, we have 3 variables which are x, y, and r. So we need to substitute r with x over 2, same like in the equation A, because we just want 2 variables of x and y. So it would be xy plus pi times x over 2 square. X power of 2 is x square, 2 power of 2 is 4. So it would be xy plus pi x squared over 4. The y, we can substitute it with the value of y that we get in the equation A, which is 400 minus pi x over 2. So it would be x times 400 minus pi x over 2 plus pi x squared over 4. So it would be 400x over 2 minus pi x squared over 2 plus pi x squared over 4. After the simplify, you will get 200x minus pi x squared over 4. So it would be the answer. So let's see for the question C. Hence, find the maximum area of the running track. The area is 200x minus pi x squared over 4. We have to differentiate the area, so the A over the x equal to 200 minus pi x over 2. And then, let the A over the x equal to 0. So 200 minus pi x over 2 equal to 0. We have to times 2 to the both sides, so it would be 400 minus pi x equal to 0. Bring the negative pi x to the right side, so it would be 400 equal to pi x. And then, let x as the constant. So x equal to 400 over pi. When use the calculator, we will get the answer as 127.32. And then use the second derivative test to test the area whether it's maximum or minimum. So d2a over dx2 equal to 0 minus pi over 2. It would be negative pi over 2. When we calculate in the calculator, we will get the answer as negative 1.57, which is it's less than 0. Since d2a over dx2 less than 0, the area of the track is maximum when x equal to 127.32 meter. To find the maximum area, we need to substitute the value of x that we get at here in the area. So 200 times 127.32, we will get 25,464, and minus pi times 127.32 square over 4, and we will get the answer minus 12,731.60456. It would be 12,732.3954 meters square. So the answer is the maximum area of the track is 12,732.39454 meters square.
As we can conclude, the solution we use to find the values of maximum and minimum are succeed. There are connections between apply maximum and minimum problem with differentials and how important it is in our life. With this application, we can solve many mathematical problems in our daily basis, work and studies. So that's all from us. Thank you.